So I'm going to go quick on some sections and then slow down on others. The wording of the problem is not my favorite because it kind of changes and it's a little vague. What we're trying to find the mean of is the rating. Is the rating of what the difficulty on the 7-point scale for the ease of question or single ease question of adding channel on their cable TV to a list of favorites. Who people say is the population here might vary. I would say it's probably people who have added a channel on their cable TV to a list of favorites. These are just the ones who gave their opinion on it. You could make it a little broader than that, but wording is not my concern for this one. So I'm pretty much going to say the mean of the rating wording and just be okay with the fact that I'm not concerned with that right now. So we start with what 3 words? Or what 4 words? Want to estimate. So we want to estimate what? Mu, which is the true mean rating, however you choose to word it, for whatever, with 95% confidence. But that part should be pretty good. I know the wording of this is going to be weird, but other than that, I'm good with that. In plan, my first thing is method. What do I write as my method? And because I've graded a lot of these and I know what's going to happen, most people who are going to miss something are going to miss what? So if you're grading somebody else's, make sure you look for that. Tell them if this is missing, they need to add that in there. What's my first condition? And a lot of people are going to miss something here right now. What does the problem directly actually literally state? So it is stated that it is a random sample. But I need you to differentiate that it is what and not what. So a lot of people are going to just forget to write that part. What is my next condition? All right, so let's go through the ones where it could be easy. What's one of the ways that this could be easy? If it was stated the population distribution is normal, which is not the case here. The other way it could be easy is if what? If central limit theorem for our sample size were at least 30. Neither of those apply, so we have to do the graph. So being picky about what I need on the graph. This is a histogram of values. And why I'm being picky about that is because eventually we deal with 4-step process where we're going to do histograms of different things within the 4-step process. So I need to know that it's specifically of the values. Writing histogram of the ratings would be fine. It's just like we end up getting into residuals and stuff, and this is not a histogram of residuals. So histogram of values. Now, the other thing I need to see is how you chose to split it. I think I just left mine the way that the graph made it. How do I know what these numbers are that I'm writing in? How do I find those numbers? My calculator made this graph for me. How do I know what those numbers are? Trace. So beside graph is the top left, top right. One to the left of that is trace. So if you click on it, it'll tell you where that bar went from. When you're in the graph, if you hit trace, then it'll you can click to the right and you can see which each bar starts and stops at.
Oh, I see.
And then okay, I might have changed mine then. Yours might say something different this one. So you would already know what yours is.
That's what mine says.
So then that must be the default one. The other thing, and I don't think the actual scaling of it changes when I do that.
But it doesn't show the values of the It shows us how much is it. So in a sense, the numbers that they're talking about are those top numbers. They're not actually talking about what's on the Excel.
Yeah, those are.
Those are ones.
Yeah,
Okay,
uh-huh.
so it's that number, that's what the Excel.
That's where that one starts, like, that's where that part starts.
Okay.
Okay, so I need to see that, and technically, I don't have to see numbers over here, because I'm not concerned with how many it is, I'm concerned with like relation to each other. So as long as you draw it proportionally, yeah.
The question I got is like, the graph doesn't look normal.
Right, and that's where I started talking about, let me finish this, yes, I agree. I think those are, no,
Yeah, no,
I'm off by one, right? Just a second, yes, okay. So those two are the same, and this one is the same height. And this one is like 150% of that, it's like here. This one is probably here-ish. So I'm not concerned with what this number is, I'm concerned with where they are in relation to each other. So as long as this is drawn to scale-ish, I don't really care how many there were in that group. Now, so that is what I have to have. Now, technically, if I just have those written down, that's enough, because I can take 8.5 minus 1 and divide it equally in between how many there are. So technically, that is fine, especially if you have to write numbers like something hundreds of thousands or something, yeah.
So my graph looks different because I had to do it in mine. Is it like, if it was like different than that, would it matter? Or are you looking for like a specific graph in your grade?
I thought they all looked really close to this. You might have typed it over.
Yeah, that's what mine looks like, but that's different than on the board.
Okay, so I have, but I'm like up and down here one, up and down here one or something, and an extra bar in there. Yes, it's different. So I changed this to make it maybe look a little bit better, but it really doesn't make it look that much better. You can change it, you don't have to change it. So let me talk about what I need on the quiz first, and then I'll address his issue, which is an issue, yeah.
no problem, I have 6 bars.
No, so I changed my whole scale to change everything. Your graph is graphed the way that one is, so you would just graph it that way. All right, so what am I checking for this graph? 2 things. I want to make sure there's no what. So, and we're actually going, and I'm just going in the order which I usually say it. It doesn't mean it's perfectly bell-shaped, it can't be wrong. There's no really strong skew. And it's not even saying there can't be outliers. There are no extreme outliers. So what we're checking for here is basically, is it so absolutely terrible that I couldn't possibly use an estimation? So does this graph look good? No. Does this graph look so terrible I can't even think about it? No. I would, if this were a problem on my quiz, I would get people who were thinking far into it, and they would write something like, this isn't perfect, your numbers might not be great, so be careful with your estimation. Which basically means the idea of, don't bank your life on it, but this is probably going to give you a little bit of insight. So if you wanted to go that far, you could technically, like, that's the idea of what's going on here, but this is as far as I need you to show, basically say, it's not so terrible that there's nothing I can do about this. So we're going to use normal approximation, yes.
So it's normal because it doesn't have a strong skew and because it doesn't have extreme outliers.
This is the idea of robustness, which is that thing that I'm going to talk about more. It's robust, which means we can still use it even if it's not perfect. So we're not saying it's still normal. This is why this part's so important.
It's like it's close enough.
And this is why we say, I make such a big deal about normal approximation and not normal, is that it's, I'm not saying it's perfect. I'm saying I can use that sheet to gain insight. It's not to the point where I can't, like, that doesn't even give me anything helpful.
How do you get to that screen where you need to scale?
Window. Like, I think it's top middle. Alright, so my next one is, what? which is, and y'all do well with this, so I'm gonna write quicker. Capital N is greater than or equal to 10 times N. What was our sample size? 10 times 14, so 140. And I'm not gonna write this out. This is the wording part again. There are at least 140, I would say, people who have used this to change channel, like that kind of wording thing. It would be more clear on quiz problem. Any questions with that? Are y'all okay with me just saying 140 population? Alright, so then do, and I'm gonna shorthand this so that I have enough to be able to write it. You get a T of 2.160 using a degrees of freedom of 13. So I'm skipping writing the top part out just because it'll all be written here. So you should have gotten an X bar of 3.7857, a T of 2.160. Your S, not sigma, should have been 2.3592. And your N was still 14. So your lower bound should get 4238, which is less than or equal to mu, which is less than or equal to 5.1476. Which could then end in, we are 95% confident that mu, the true mean rating, however you do your context, will fall between, my best bet for units here is say a score or a point of, probably say points, 2.434238 points and 5.1476 points. Any questions? So if you marked on somebody else's and wrote stuff down they did wrong, make sure you share that with them.
When you're doing that in the calculator,